So wonderful, guys. Good going. So with all of that, I think we'll start with the theory. So since display is one thing which we haven't learned so far, I'll be first briefing about the display which we are using, which is OLED. OLED stands for Organic Light Emitting Diode. And this is basically how it looks. So you see 4 pins here, right? So VCC stands for the power, the port which you will connect the power to. GND is ground. SCL is serial clock input, and SDA is serial data input slash output. We're going to be using I2C communication. So this is the communication protocol which you guys covered in the last session, and we're going to be using that today. So the memory map, like, this is not really, what we're going to be using. This is just for letting you guys that it has 1 kilobyte of memory, which is allocated as follows. Like, it has 8 pages, like from 0 to 7, and each page has 128 segments or columns. Like, it's just division amongst the memory. That's it. I'm just letting you guys know that's it. And each segment has 8 bits of data, and total that converts to 1024 bytes or 1 kilobyte of memory. And where is all of this stored? It's stored in the graphic display data RAM, GDD RAM. That's where it is stored. And you need to know about the coordinate system of OLED. This is very similar to what we've always done, like the horizontal being the X direction and the vertical being the Y direction. But this is how it is defined. Like, this is like the force coordinate of the rectangular Cartesian system, right? It's exactly like that. But if you see, the pixel which we are denoting, it's at the center. So if I'm talking about 18,6, it is this whole block, like a block of 1 unit length and 1 unit breadth. That's how it is. And you guys will need to know this properly because we're going to be using this to build the game, right? So yeah, with that, I think we'll go to the OLED library which we're going to be using, which is called Adafruit. You guys need just know this much. You don't need to go through theory and all. If you want, you guys can read this later. And with that, I think we'll go to the simulation of OLED. Pretty simple simulation actually. So you guys can open Wokwi because this is the platform which we are going to be using. So Wokwi, I hope all of you guys have account on that. I'll share that screen just a second. Yeah. Okay. Hope the screen is visible. All you guys need to do is go to wokwi.com. The first site which you see is the one which we are going to go through. And this is logged in by default. If it isn't logged in, you guys can go and log in. And we have talked about this in the previous session also. I'll give you guys some time, like some 2-3 minutes so that you guys can log in. Are there any doubts so far? Let's go through. No doubts, fine. Not done anything complex. Yeah. Once you guys are done going through Oakview, right, just react, like put a thumbs up or something. Okay, see 3 thumbs up. Nice. Nice. So I hope everybody is logged in now. So we'll start with the session. So here you're going to be again working with ESP32. That's why we're choosing Walkway again. You guys can go to this top left, top right icon and press My Project. And we're building a new project from scratch, right? And click the first board which you see, ESP32. And go for the beginner templates, Arduino template. So yeah, here is our ESP32. And to this we are adding an OLED, Right, so I'll go search for OLED here. Go choose the first display which you see. Right, this display. Okay, so yeah, with that done, we'll start wiring this. So here in Walkme, the color coordination is by default done. Like for the 5 volt and ground, it's already done. If you want, you can give different colors for SCL and SDA. So first we'll connect the ground. So this is the ground pin, the top right pin, and we'll just put it on the ground here. Just click this, drag, and click the other end to the pin where you want to connect it to. So we'll do the same for VCC. So the 5 volt, which is the left, the last one which you see, press it and drag it to this VCC port over here. Okay, and then we'll connect the SCL and SDA. In the ESP32, by default, the SCL pin is the pin number 22 mentioned here. So pin number ESP22 is the pin which you'll have to connect to SCL. So be careful about these pins, like you shouldn't wire it to anything else. So SCL to pin 22 and SDA to pin 21. So basically this is all the wiring which you're going to be requiring for this. So the setup is done. If you guys have any doubts, you guys can put it in the Q&A. I'll check that. No doubts so far. Okay, pretty good. Are you guys done with the basic wiring? Can we start with the code? If yes, then just put a thumbs up. Only one person has done. Okay, I'll give you guys some more time. So SCL is connected to pin number 22 and SDA to pin number 21. Ground to ground and VCC to the 5 volt. This is all we have done. So hope you guys have done this part. So we will start with the coding now. So basically you will need certain libraries for this. And the first one being wire.h. So wire.h is again used for ICC connection, right? So that's what we're going to be using. Capital W, guys, be careful about that. So that's the first library we are going to be using, wire.h. And the second library we're going to be using is Adafruit library, which I already told you guys. So this is the library which you're using for displaying stuff. And this is this library, like Adafruit SSD1306.h, because this is actually 1306. SSD1306 is the name of this display. So these are the two basic libraries we are importing, and we'll given the basic parameters now, like the screen width, height, and the address, reset pin, all of that. So these are just constants. You guys need not worry about this. So the screen has a width of 128 and a height of 64 pixels. So that's what we're going to do. So we'll declare it as an int data type. If you want, you guys can use constant also. That doesn't matter. So screen width equals 128 int screen. I'll put caps. Height equals 64. So width and height done. There is an internal reset pin which we'll have to define. You need not worry about this at all. These are just constants you're defining at the beginning. And there is an address. Like any display, this also has an address which is 0x3 capital C. Okay, and these are all the basic stuff we'll have to define. And then we will initiate the display right now. So the function is add a fruit SSD 1306 the display, and it takes in some basic parameters like the screen width, height, reset and address. These are that's why we have defined it before. So if you don't want to give it as some variable, you can directly put stuff here. But just for good programming practice, we prefer declaring variables there. Screen width, height, and wire. Like this is that I2C thing which we're using, right? So we're using that reset. So with this, the screen gets initialized. So we'll go to the void setup now. Void setup contains the stuff which I run only one time during the program. So I'll just use a serial monitor so that I can print stuff if required. This is kind of like just for testing purposes, but we'll just use it. And baud rate will give the traditional one, 9600. And so we'll have to check if it is connected, the ESP32, and the display, if it is connected, it's well and good. Otherwise, we don't want it to go into the void loop, right? So this is kind of just checking if we have done our connections properly. So if display is not connected, so the function is display dot begin of, and it takes in certain parameters, which is called as SSD1306. Wait. BCC, comma, address. So you guys may be wondering what this switch, what this variable is. So this is an inbuilt variable which will power the display. That's it. And address we have already defined before. It is the physical address of that screen. And if this exclamatory tells that this is not true. So if the display is not connected, then we'll just print it in the serial monitor. Print ln of display not connected, that semicolon, and we'll just not break the loop and keep it. Like you might be wondering what this for semicolon stands for. This just does that we are creating an infinite loop which has no purpose. It just doesn't exit this loop. That's it. So with that done, the void setup part is completed. So we'll go to the void loop part. This is the part which is going to be run on loop. So for the display, you'll have to initialize the text color, text size, and where you want to put the monitor and what you want to display. All of that we are going to be defining here. So this display actually supports only black and white colors. And black color, if you write also, you're not going to be able to see anything. So we'll stick with white. So first I'll set the color. No, size. I mean display dot set text size. So first I'll just give you a size of 1, and you guys can run it multiple times with changing each parameter. You'll see the difference. I'll be showing you just two different sizes, and then we'll set the color, set text color, and we'll put that as white. And we'll set the display at the cursor at 0, 0, which is this point, the left uppermost point here. So that's 0, 0. Display dot set cursor at 0, 0. So this is like the basic things which we have been always doing, right? A regular Cartesian coordinates. That's it. And then we're going to display hello world. Okay, so we'll write display dot println. So you're using println because you want that to be printed in one line. And the next thing whatever you're typing will get printed in the new line. That's the thing. Hello world. And then there is this function called display dot display off. So what does this do is that if there is something in the memory buffer which still hasn't come to the screen, it will push it to the screen. That's all this is supposed to do. And we'll delay it for say 2000 milliseconds or 2 seconds basically. And then we'll clear the display. Display dot clear display. What have we done so far? We have set text size to 1, text color to white. We have put the cursor at this top leftmost corner and we are printing hello world. We are displaying it. We are delaying it for 2000 milliseconds and we are clearing it. So just to show you guys the difference, right? Like the size difference, which is kind of possible. I'll just copy this thing and I'll paste it another time so that I'll put this size to 2. I'll put the coordinates somewhere else, say 0, 5, and I'll just print hello. Okay, so this is the basic coding part. We are done with it. So you guys, I'll give you guys 2 more minutes to complete this part. And in the meantime, if you guys have any doubt, put it in the Q&A part. We'll clear it for you guys. No doubt so far. Nice. So you guys are just following this, I presume. If you guys are done, just react, like, thumbs up or something, so that I'll start with the simulation. So I'll just go through the code again so that you guys have time, in case you guys are doing anything, you will have time again. So the basic library which we're including is the I2C library, wire.h, and Adafruit SST1306, which is this display. And we are initializing the screen width, height, reset, and address so that we can initialize it here. Adafruit SST, and all of these are capital actually, SST. Sorry about that, just correct that part. Screen width, screen height, and wire and reset. And we'll go to the void setup, and we're initializing the serial monitor. And if it is not getting, if the display is not connected, then it will print display not connected, and it will forever be in the loop. It won't come to this part, the void loop. Otherwise, you'll get unnecessary errors, right? So that's what this part is actually for. And then we've come to the void loop. We're setting text size, color, position of the cursor, and the message which is to be printed. We are displaying it for 2 seconds or 2000 milliseconds, and we're clearing the display and printing another message. So I've actually put this part so that you guys will see the void loop running. That's all. If you guys want, you can put only the first part. That's fine. So we'll start the simulation of this. So in the beginning, you're bound to get errors telling that, these two libraries are not there. You can install it. So you can see, right? Adafruit SST1306 library. Just click install. So in the library manager, it will show you this library being installed. So you guys can go back to sketch.ino again and start the simulation once more. And if there are no errors, then you will see the display, like, stuff being printed on the display. What is for semicolon, semicolon do? It's just a basic loop. Like, it's a never-ending loop which does nothing else. That's the only thing. Do we have to remember the code for real purposes? I think you guys can always refer to this. But this code is necessary every time you're using an OLED display. What is the use of EMT for the loop, for loop? Oh, it's just that it doesn't go to the void loop, so you guys can avoid whatever errors, Otherwise, it's going to throw errors like the display isn't initialized or something like that. Is there any advantage of using ESP32 over Arduino for OLED? I don't think there is any difference, but since we already introduced you guys to Vokvi and ESP32, and ESP32, as I said, has slightly greater advantages as compared to Arduino, we're doing that. That's it. So you guys can see it is running, like the text difference you can see, and the cursor position also, like hello world is printed in the first part, and see it's come down. So that's basically how it is done, because it's x comma y, right? And the y coordinate we have changed here to 5. So pay fifth pixel, this is going to be printed. This is basically how this works. Why do we need infinite loop in setup part? I hope I've cleared that doubt. It says build failed. So Oh, it's commented in. Yeah, you have to try compiling it. Somewhere the connections you might have not done properly. That's the only thing. Otherwise, it should be working properly. So I'll just wait here for a minute so that, in case you guys have any other doubts, you can comment that. And we'll resume with the theory part again after this. Unexpected. Have you missed some semicolon or something somewhere? That's what it is saying. You've missed a semicolon somewhere, Isha. Just correct that and I think your code should be good to go. So this code is kind of important. Just save it. Reset is like it's some internal classification. That's it. Like certain initializations you'll have to do, right? So this is reset equals -1 is one of those. So make sure you guys have gotten this properly because with only this you'll be able to proceed further. Like this is kind of the basic foundation for your game building. So make sure you guys have properly simulated this and you guys are getting no errors. Because we'll, and save this because this is what we're going to be building the game with. We'll just add a few push buttons and change a bit of the code and you guys should be good to go with the game. Okay, so I think you guys are all done with this part. I'll just rush you guys through some, basic terminologies and then you guys can start with the game. Just a minute, I'll reshare my screen. Hope it is visible. So this is a model simulation which I've put. If you guys want, you guys can refer to this later. So with that, we'll come to something called pull up and pull down resistors. This terminology is kind of important because only then you'll have properly functioning, push buttons or anything in general. So what does a pull up resistor do? By default, what it says is that that device is pulled to a high state. Now, what exactly I mean by this is that let's say this there is this push button and this configuration is pull up. So why am I saying that? Is because you see this is connected to the 5 volt, right? That resistor was connected to the 5 volt, and now this button will act as a as pulled up part. What it means is that when I press the button, right? That is when the switch is closed, the input is high, and when the switch is open, that is when I don't press it, it is low. That's basically what it is. Okay, there's something called as pull down resistor, which is the opposite. So by default, it is in a low state. So what do I mean by that? Is that we'll go to the same example, but now this resistor is connected to the ground part. So so what I'm telling is that when the button is pressed, that is when the switch is closed, it is in a low state, and when the switch is high, when the switch is open, it is in a high state. That is when it is not pressed, it is in a high state. Okay, so that's the basic definition of pull up and pull down. So with that, I think we'll go back to that simulation which we had and we'll add the few push buttons which we need so that, you guys can start coding the game. So I'll go back to the project. Like hope it's visible, my screen. And I'll stop the simulation here. And I'm going to be adding two push buttons, one for moving right and one for moving left. So I'll go here. I'll get the push button and press keyboard. On the keyboard, you can press an R or you can press this key, right, which says rotate. It's gonna rotate it this way. And I'll add another push button. This is for the left and this is for the right. So yeah, so we got two push buttons ready. Now we'll do the wiring part. So we're gonna be having pull down resistors here. So I'll add the resistors. You can keep the default resistors, that's fine. I'll rotate this also, this resistor. I'll connect it here. They're properly connected. One more resistor I'll add. I'll rotate this. Get it here. I'll rotate that push button. I'm sorry, the resistor, and I will put it here. And both these you have to connect to the ground now. So ground. I just move these push buttons a bit down so that it doesn't interfere. If you want, you guys can connect these tools like better, you know. I don't want any wiring issues there, right? So that's the control press and control minus for zooming in and out of this place. So we've connected that to the ground, and then we'll connect it to the 5 volt. So you guys already know about the wiring of a push button. It was discussed in session 1. Just using that only here also. Okay, with that it's done. So you need a pin, for, you'll apply digital read, right? So for the left button, I'm going to be using pin number 16 here, ESP16. That's the pin. And for the right, I'm going to be using pin number 18. So this is arbitrary, but you'll have to define it in the code. So if you guys want, you can use any other number. Like that's all up to you guys. But in the, in the code, you'll have to accordingly modify it. That's it. So basically, our push buttons are now connected. And I'll just add an LED again, which is something you know. And why am I using this LED? I just want to blink it, when the ball hits the paddle or when the game gets over. For all of that, I'll include this. I'll add a push button, I'll add an LED. Again, the wiring of an LED you guys have already done. And again, I'll use a resistor. You need not change the value. You can keep it as it is, 1 kilo ohm. I'll rotate this and I'll add it there. Looks a bit messy, I'm sorry about that. But yeah, this is how it works. Okay, and then I'll connect this to ground. And again, for blinking the LED also, you'll have to connect it to some pin in the ESP. So I'm using, say, pin number, I think I'll go with pin number 19 here. So yeah, done. So this is all you need for building your game. So what have we done so far? We have wired your OLED screen and we have added 2 push buttons and an LED. So all these connections you guys already know. So I hope you guys are finding it easy here. If there are any doubts, just put it. Can you please repeat the construction? I got disconnected. Yeah, sure. So it's basically like the OLED you're connecting to VCC and ground, and the SCL goes to pin number 22 and SDA goes to pin number 21. And then you have connected two push buttons. So push button is we kind of using pull down resistor. So we are connecting the resistor to the ground part. That's all we have done here. And we have connected the other end to VCC. And you'll have to, check if the push button is pressed or not. So you're connecting it to 2 points in the ESP32. Can be any 2 points, but you'll have to accordingly define them in the code when you're writing. And then I have added an LED. Oh, the other end I haven't connected. I'm sorry. Wait, I thought I did connect it. My bad, I connected it to the wrong thing. Just a minute. Sorry, It's from this thing to pin number 19. Sorry about that. So hope you guys are done with this part. And with this, I think I'll hand the session to Deepti, who will be explaining you all the coding part. Oh, yeah.
Hi guys, let's get started with the creation of the game. So I'll be teaching you stepwise how we proceed in the game to make that ping pong game. Okay, so let me share my screen. Yeah, is my screen visible? Please give a thumbs up if it's visible. Okay. Um. So let's get started. Now, what is it that we will be needing to make the game? Anybody can guess what is it that we will start with? The first thing that we will need to make a ping pong game. Any guesses? Okay. So we will be first starting with making a ball and a paddle. We will first create a ball and a paddle. That is using some functions that are a part of a library called Adafruit GFX. So let me go here and add another library, which is yeah. So what is this library for? It helps us create different shapes. It helps us create shapes of different sizes. All the graphics related drawing and all that come to use that we need a few functions. We take the help of the functions which are a part of this Adafruit GFX library. So let's proceed and first create a ball and a paddle. For now, I'm just going to clear this part. Hope you all are with me. If you think I'm going fast, please let me know so that I'll slow down. So let me make it as display dot fill circle x1 y1 comma 2 comma white. So what does this mean? So here x1, y1 are the coordinates of the center of the ball, and 2 is going to be the radius of the ball, and white is the color that we have chosen. So when I write display dot fill circle x1, y1, 2 comma white, I will be creating a ball that whose center coordinates are x1, y1, radius is 2, and color is white. Now let's make a paddle. Paddle is basically the rectangle that will on which the ball will hit. So display dot fill rectangle x comma y comma 20 comma 4 comma white. So what are the inputs that we are giving to this function? X is the X and Y are the position coordinates of the top left corner of the rectangle, and 20 is going to be the length of the rectangle, and 4 is going to be the height of the rectangle, and white will be its color. Okay, so let's now we will write display dot display. So what does display dot display do? If there are any changes that are being made, that those changes will be updated. Okay, so we are now done with the creating of the elements that we need for the game. What is the next step? Next will be to define variables. Now what are the variables that we might need? We need one for the position of the ball, one for the position of the paddle, and one that will tell that are constant variables, basically the speed coordinates. That is what is going to be the speed of the ball. And there is also one important part of the game, that is going to be score. So score is also a variable that keeps getting updated every time the ball hits the paddle. So let me define a few variables here. First being int x1. Yeah. So x1 is going to be the center of the x coordinate of the center of the ball. So let's say when I start the game, the ball starts from, say, x1 equals 64 and int y1 equals 32. Okay, so this means that at the start of the game, the initial coordinates of the ball will be 64, 32, which is exactly at the center of the OLED screen. Now the next variable that I define will be for the position of the rectangle. So notice that because I'm defining here as x1, y1, because while creating the circle, these are the center coordinate variables that I have used. So for rectangle also I will be doing the same. So I'm going to take an arbitrary value for the start position coordinates of the rectangle, which let's say is 55, x equals 55, and int y equals, that will be, let's say, 60. Why is it? Now there's a reason why x, though it can be anything, because paddle, as Akshaya showed in the slides, the paddle will be moving and on the lower base of the screen. So the x value will keep varying for the paddle, but the y value will remain constant, and that is equal to 60. Why? Because the height of the rectangle, as we have defined, is 4. So hence y ka coordinate will be a constant throughout the game. Okay. So these are the I'll add comments for clarity. Position coordinates of the center of the ball, and these are the top left corner coordinates of the paddle. Okay. Now I will define a speed variable. Let's say that is int x speed, that is equal to, say, 1, int y speed, which is equal to 1. So this is going to be the speed of the ball. Okay, so why have I defined x speed and y speed? I will be eventually adding it to the position coordinates of the ball. Okay, so these represent the vectorial, like if I have to write the speed of the ball, it will be 1 x cap plus 1 y cap. Okay, so now of course the most important part, score. So at the start of the game, score is going to be 0. Okay. Hope I'm clear. I hope everybody is going along with me. If I need to slow down, please let me know. Okay. Now, okay, before starting anything, there is something that I've forgotten to do, and that is to define the pins. Akshaya has connected push buttons and LEDs for me, and I have to define them. So let me do that. So here I will say pin mode. Okay. So this push button is connected to the 16th pin. So I'll write it as 16, comma, and it's going to be input pull down. Why input pull down? Because it is the resistor or attached to the push button is connected to the ground. So that's why input pull down. And when I say input pull down, I mean that when the push button is pressed or when the switch is closed, the this goes to high. Okay, the pin goes to high. Okay, what part should I repeat? Can you please let me know what part should I repeat? I will repeat that. Okay, so I'll continue. If there is anything that I need to repeat, please let me know. Okay. Do you want me to repeat from the start? Okay. So what I have done first is that I have created a ball and a paddle using these two functions. Okay. So that is fill circle and fill rectangle. Paddle is rectangular, and this in circle, the inputs that I'm giving for this function is x1, y1, 2, and white, where x1 and y1 represent the position coordinates of the ball, 2 is the radius of the ball, and white is the color. And fill rectangle may I have x and y, which are the top left corner coordinates of the rectangle. 20 is the length, and 4 is the height of the paddle, and white will be the color. When I say display, I mean that whatever changes that happen at every time during which the game is running, I want those changes to be updated. So display will update the changes. Okay. And after this, I went to in create some variables. One for the position coordinates of the center of the ball represented by x1 and y1. And at the start of the game, the x position of the ball is 64 and y position of the ball is 32. Then I defined coordinates for the paddle, which are basically the top left corner coordinates, which is 55 and 60. And then the speed, I'm keeping it as 1, comma 1, and the score initially is 0. Any doubts? I hope I'm clear with the part now, and I request all of you to please be along with me so that we can, complete the game together. Okay. So now what is the next step? Let's check. I have created all the variables. Next is the movement of paddle. Now there are push buttons and I have to define how the paddle will move every time I click a push button. So let's do that. But before doing that, the most important thing, I have to define pins. Let's do it. So the other push button is connected to the 18th pin. Okay. And then I also have an LED which is connected to the 19th pin. And that will be declared as output. Okay. Now after this part, I will add one more thing that's going to be display dot clear display. Okay. Yeah. Yeah. So why clear display? Why this function? Because when the code starts to run, I want at the start of the game, I want the screen to be clear. With clear screen, I will start the game. Let's run this loop. Let me add a delay of 1000 this 1 second and show you how the ball is all the rectangles are appearing. Okay, it shows some error. Shouldn't show, but let's see. Um, can see the problem right now. Okay, we'll just continue and we'll see. Okay. We'll just see, we'll carry on and we'll see, we'll continue. At least I'll try to explain you the coding part. Okay. So we have declared, now we will, you know, uh, see how the paddle will figure out the code for the movement of paddle. So let's see. Okay. Now I'll write code for movement of paddle. Now I will define two more integers, k1 and k2, which are going to read the values of the push button. Okay. So int k1 comma k2. So let's say k1 equals digital read of, let's say, this push button. This is connected to the 18th pin. So I'll say 18. Okay. Now, if k1 equal 1 and x plus 20 less than or equal to 127. What does this condition mean? That is, let the ball is moving. K1 is equal 1 means that the push button is pressed, and x plus 20 less than or equal to 127. X, as I told, is the top left position coordinates, and if that is plus 20, which is the overall length of the paddle, if that is less than or equal to 127, that is, the paddle is within this screen range, then I will write x equals x plus 3.5. That is, I am saying that the x coordinate should be increased by 3.5, which means the paddle will move to the right by a distance 3.5. And for clarity, I will write serial dot print line right, which means in the serial monitor, I will see right when I press this push button. Okay. Now, for the second push button, which will make sure that the paddle moves to the left, it is connected to the pin 16th. So very similar, but since it has to move to the left, I will be subtracting 3.5. That's the difference. So this will be K2. That will take the reading from the 16th pin. Okay. And here, if K2 is high and x is greater than or equal to 1, that is, it is greater, it is in the screen, then x becomes x minus 3.5 and serial print line will be, it will print left. Okay. So with this code ensures this code checks for the movement of the paddle. So with this, we are done with how the paddle will be moving either to the left or right. Okay. Let me try running this code. Oh, and I forgot to add semicolons. Good. So to add a semicolon, we do that. I think apart from this, I don't see any problem. If you guys know anything, please let me know. Okay. So now we are done with the code for the movement of paddle. What is the next part? Next part will be writing an if condition for the scoring case. That is when the ball hits the paddle, which we will cover a little while later. The next one is boundary conditions. What are boundary conditions? So boundary conditions is basically we are playing a ping pong ball game where the ball is obviously hitting the edges. It's hitting these boundaries. And when it hits the boundaries, the direction of the speed changes. So we will be noting down those changes. Okay. So um, let me start with that boundary part. Okay. Now these are boundary conditions. Okay. So first, let me write for uh, the edges, the left and the right edges. Okay. So let me say if 2 less than x1 less than 125. So what does this represent, this condition? This represents the boundary which are located at the left and the left and the right edges. Okay. This basically represents the left and right edges, and 0 less than y1. Okay. So what happens when the ball hits the vertical edges? What happens? The direction in the speed in the x direction, or okay, let me write this. So this is basically the, sorry, I made a mistake. This represents the case where the ball is moving in the screen. So in this case, it will be x speed equals x speed and y speed equals y speed. Okay. Now the next case is when it is hitting the left and right edges, which is given by if x1 equal 125 or x1 equal 2. What is this case? What is x1 equal 125? The rightmost edge. What is x1 equal to? The leftmost edge. Okay. So in that case, the direction, the x direction, the direction changes, but the y direction remains same. So I will write it as x speed becomes minus x speed and y speed becomes, it remains, the direction remains the same. Okay. This is for the left and the right edges. Right. Next one is when the ball hits the uppermost edge. So if z1 equal 2, that is, this is 2 is going to be the uppermost edge. This is going to be y1 equal 2. What will happen? The speed in the y direction, the direction of the speed y speed changes, but the x speed remains same. So I'll write it as y speed equals minus y speed, and then x speed equals x speed. Okay. Yeah. Now we will come to the scoring part. That is when the ball hits the paddle. So basically we have covered the left, right, and the top edges of the edge conditions. Now what happens when the ball hits the paddle? Let me add a comment here that says this is for the top edge. Okay. Now what happens when the ball hits the paddle? There is an increment of score. Okay. So let me write it as, okay, I'll write it as if x less than equal to x1. So x1 is the x coordinate of the center of the ball, and the x is the top left corner position coordinate. X less than or equal to x1 and x1 less than or equal to x plus 20. So what does this represent? X1, that is the position coordinate of the center of the ball, is between it is a bit, it is lying in the paddle area, right? So um and z y1 plus 2 equal 59. So this represents the case where the ball has hit the paddle, where it has touched the paddle. Okay, so in that case, what do we do? First, of course, the most important thing, the score increases. So I'll and of course the speed, the direction changes. So I'll write y speed equals minus y speed. Okay. Um, and x speed equals x speed, and score gets incremented by 1. So score equals score plus 1. Okay. Um, and since I've added an LED light, I would want it to blink for say a short time when the ball hits the paddle. So I'll write digital right 18 comma I. It will be delayed for 20 milliseconds, and then digital write 18 comma low. Okay, so this is for the case when ball hits the paddle. uh Now let me try running it, but I think it might show an error again. Okay, I made a mistake here. The LED pin is connected to 19th, so this should be 19. Let me remove this. And one more thing, I forgot about that. How do we relate the position of x1 and x? So the speed keeps getting added to the coordinates of the ball. So I will write x1 equals x1 plus x speed, and y1 equals y1 plus y speed. Okay. Now let's see. Okay, showing an error again. There's something wrong with the declaration of variables part. Let me check that.
Deepti,
Yeah.
in line 9, you haven't given a semicolon after y1.
Oh, thanks.
That's try running, no.
Yeah. Guys, for some reason it's showing the error. Do you, if you get the code, please help me. Anybody has got any? So you're suggesting I should use A and B instead of X1, Y1? Okay. So let's try doing that.